Lab 5, the falling Slinky. The purpose of this lab is to model the motion of a stretched Slinky as it is dropped from an equilibrium state to the ground. Some of the fundamental principles used in this lab are Newton's second law, which states the net forces of an object equals its mass times acceleration. Hooke's law, the spring force of an object equals the negative Ks times S, which is the negative spring constant of the spring times the length of the string. The energy principle, where the change in energy equals the change in kinetic energy plus the change in potential kinetic energy, and then the change in the potential spring energy. The kinetic energy, which is 1/2 mass times velocity squared. Spring potential energy, which is 1/2 the spring constant times the length squared. And gravitational potential energy, which is mass times gravity times the height of the object. Some of the models used in this lab: the observed model, which is the video of the Slinky being dropped from rest, and then the data from the observed model, which was used to create a computational model using GlowScript. Some of the initial variables of the model: the mass of the Slinky, or the average Slinky, is 0.25 kilograms. In a stretch position, the bottom of the Slinky is negative 1.287 meters below the top of the Slinky. So the Slinky stretch is about 1.25 meter. And the Slinky has 0 initial velocity. Here is the observed model. As you can see, the Slinky falls, and as it falls, the bottom of the Slinky is tracked using tracker. And at the beginning, as you can tell, the bottom of the Slinky stays in one spot, and then once the top of the Slinky gets to it, it begins to fall with the rest of the Slinky. All right. Here is from the GlowScript, where we entered all of the initial data and the other data to calculate and find the forces acting, and use the forces acting on the Slinky to model the Slinky. We can see that it stays at it's the position that it was at until the top of the Slinky reaches the bottom of the Slinky, and then the position of the bottom of the Slinky also begins to fall, as we observed in the observed model. And here are the two models next to each other. The dots are the actual model, or the observed model data, and you can see that it is a little bit off of the actual model, but they follow a very similar path and are very similar to each other, showing that the model did a good job of predicting what would happen as the Slinky fell. The deviations could have also come from external forces that were not factored in to the model. For furthering the lab, one thing I'd like to look at is how the top of the Slinky fell from the top to the bottom, and seeing how the spring force affected its velocity as it fell to the ground. In conclusion, the modeling of the Slinky with the GlowScript was quite well.